Another way now to deal with the position and velocity and acceleration vectors and their relations together with the time parameter. If we have, for example, this is an example, if we have the position vector, which is, for example, r of t is equal to 5t squared in I direction plus 6 cosine 2t in j direction plus 6t to the 4 minus 3t cubed in k direction. It is just a moving body. In this relation, we need to find v of t and a of t, as we know from before that. V of t is just the time derivative of the position vector, and the acceleration is the time derivative of the velocity vector. Simply, if we need to find the velocity vector, we need to derive the position vector. We have rx or x and y and z, or also we can name them rx, ry, rz, or xyz as functions of t. So the velocity in x direction is the derivative of the x component with respect to time, or dx by dt. This is x, 5t squared. Its derivative is 10t. This is the velocity as a function of time in x direction. And the acceleration, we need to derive the velocity with respect to time, give us the acceleration, which is the derivative of 10t, which is 10. Also, the velocity in y direction is the derivative of y component of the position vector, which is 6 cosine 2t. The derivative of cosine 2t is negative sine 2t, and the derivative of the argument 2t is 2, and we have the 6 from before. So the velocity in y direction is 12 sine, with negative sign here, sine 2t. The acceleration is the derivative of this value with respect to t. It will be negative 24 cosine 2t. This is the acceleration in y direction. What about the z direction? The velocity in z direction is the derivative with respect to time to the z component of the position vector, which is 6t to the 4 minus 3t to 3, which is equal to 24 t cubed minus 9t squared. And the acceleration is the derivative of this function of time, which is equal to 72t squared minus 18t when we derive this with respect to time. Now, after that, we have the three vectors r of t, v of t, and a of t. We have them in three directions as functions of time for rx, vx, ax, ry, vy, ay, and the same for az. If I asked you now, when I'm asking about the time, the z velocity is equal to 0. I'm asking about the velocity, then I will use the velocity vector. The z component, so I will use the z component. I need to know when the z component is equal to 0. So I will just deal with this. Vz, which is equal to 24t cubed minus 9t squared, is equal to 0. I need to find that time. I have t squared, t cubed in both terms. Just divide over t squared, all the terms, 0 over t squared, 9t squared over t squared, 24 t cubed over t squared. Then this will be 0. Squared with squared will go with, we have 9, and here we have 24t. Move minus 9 to the opposite direction, it will be 24t is equal to 9, then t is equal to 9 over 24, which is 0.3785 seconds. This is the time. For example, we have a projectile motion, and this projectile motion in 3 dimensions. I have a motion, this is x, this is y, and this is z. And I have a projectile motion, this is xy plane, and the object comes through this trajectory, and the upward is the z direction. When is the z direction's velocity is equal to 0? It is at the highest point. This is z max. The vertical velocity at the maximum point, the maximum height, the velocity here is equal to 0. But I have x velocity and y velocity. But I'm asking about the z velocity. Now, when I find when the velocity vertically is equal to 0, then I find that time. This is the time. By finding the time, then I can apply that in, for example, in y position. Then I will find that y component, y at maximum point, and this is x at maximum point. By using the vector position and velocity and acceleration, I can easily solve a projectile motion. A projectile motion, we have it in x and y direction, and we have relations, and you can find all the properties of the system using something like this. Just use it, see what is required from you, and use just the velocity or the position or the acceleration and the desired component of these vectors. Good luck.